Going to talk about two more trig ratios. So yesterday we introduced the first one, and that was called tangent. And for tangent, we took the opposite side of the angle and divided it by the adjacent, or the side that was next to it. Today we're going to talk about two more that are called sine and cosine. Sine is abbreviated SIN, and on your calculator that's what the button will say, and when we write it that's what we'll write. But please don't call it sin. It is sine, even though we abbreviate it to sin. Okay, so it is called sine. Please call it that. When we do sine, we're going to write it like we did yesterday. That we'll write at the abbreviation, and then we need an angle. We always need an angle after a trig name. Whether we're doing tangent like yesterday, sine or cosine, we always need an angle. Sometimes that's the name of an angle, like theta or y or x or a or b or whatever the letter is that names the angle. Sometimes it's a number, like how big is the angle, like 28 or 56 or 72 or however big that angle is. But we always need an angle. Sine is equal to the opposite side over the hypotenuse side. So yesterday we did not use the hypotenuse at all for tangent. We just used the opposite and the adjacent. For sine, we will be using the hypotenuse. The other trig function we're going to do today is cosine, which we abbreviate COS. Again, we need an angle. And cosine is defined as being the adjacent side over the hypotenuse. For both of these today, we will be using hypotenuse. Now, we have three different ones to remember what all the different parts are for these fractions. So some teachers use the word SOHCAHTOA to remember what those pieces are.
Happy birthday.
So with SOHCAHTOA, each letter of this word means something. So the S stands for sine, and then OH says opposite hypotenuse, because sine is opposite over hypotenuse. Then the C stands for cosine, and then AH, cosine is adjacent over hypotenuse. And then tangent, T, and then OA, opposite over adjacent. So this lists out each of the three trig functions, and then what the fraction is. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. The problem with this is that if you don't remember how to spell it, it's no good to you. Do you need this? So if you're like, I'm not going to remember how to spell that, it's not going to be good to you. So then you'll want to come up with a different way of remembering it. One of the tricks that one of my teachers used was it ignores the S, C, and T, so you have to remember that those go there. But make up a story using the letters. So the story that she used was Oscar had a heap of apples. Kind of taking each letter there, ignoring the S, C, and T, but Oscar had a heap of apples. Or make up your own story, whatever's going to work, so that you can remember what these three fractions are, okay? Because you do need to remember the differences between them. So in this problem, it says find the values of x and then y to the nearest integer, so no decimals here. We're just going to round them up to the nearest whole number. So if I'm solving for x first, let's use the 67, since that's the angle they gave us. What kind of a side is x compared to the 67? Is it an opposite, adjacent, or hypotenuse? Opposite. And 120 is what kind of a side? The hypotenuse. So we need to pick the trig function that uses opposite and hypotenuse. So which one is that? Sine. So we're going to say sine of 67 is opposite x over hypotenuse 120. Okay, so we have to pick the one that uses the stuff that we're working with. We're working with the x's. And then we solve this as we did yesterday. To get the x alone, we multiply both sides by 120. To our calculator, we type in 120 times the sine of 67. The sine button Should be very close to the tangent button that we used yesterday. So what do we get for 120 sine of 67? Right about 110. So x is 110. Then we're also asked to find y. So y is what kind of a side compared to the 67? It's the adjacent. And then you could use the 110. I kind of always like to only use the initial given information just in case I made a mistake. Because if that 110 is actually wrong and then I use it, everything's going to be wrong after that. Whereas if I can go back to the beginning of the question, then it doesn't really matter whether that last one was right or wrong. I'm going back to starting information. That's definitely right. So I always like to go back to starting information, but you could use the 110 if you feel really confident about that answer. So using the y and the 120, the adjacent and the hypotenuse, which trig function would I use? Cosine uses adjacent hypotenuse, so we'll say cosine of 67 is adjacent, which is y, over hypotenuse 120. We solve it like the previous question, and like our questions yesterday, multiplying both sides by 120, and then typing it in the calculator. So 120 cosine of 67 gives us what for y? 46.8, 47, right about there. Since it says to the nearest integer, we'll just round it on up to 47.
This is Sarah.
Yes?
Can you send Michelle Vandervliet down to the office?
Yep.
If you do it on your phone, do we want the second on?
No, if you're doing it on your phone, you don't want the second or the shift button on. We want just the regular for this. We do the second when we're solving for an angle size. Okay? When we're solving for an angle size, that's when we need to be doing the seconds.
With the angle, does it matter if it's across from the side you're trying to find, or you just use whatever angle you're doing for both side and side?
You could use either angle, the 67 or that other one up in the corner that we didn't find, which is 23. But whatever you use, just label your opposite and adjacent according to that, and then pick the correct trig function. So you could use either angle, but it's going to change which trig function you use. So just label according to the angle that you pick. The second example then says, find the value of n, which is an angle in this question. So we're looking for the angle. What kind of a side is 22? The opposite. And 40? The hypotenuse. So if I'm using opposite and hypotenuse, which trig function am I going to use? Sine. So we're going to say sine of n is 22 over 40. And when we're solving for the angle, this is where we did the second. So just like yesterday, you're going to need to press second, but then we're going to use the sine button instead of the tangent. 22 over 40. Okay. When we're solving for an angle is when we use the second to get the inverse of whatever trig function we're using. Be careful that you're just paying attention to which button you're pushing. Yesterday we just hit tangent every time. It was always tangent or second tangent, tangent, second tangent. But today now we have options of what button we're doing. So always make sure that if we're doing sine in that question that you're pressing the sine button. Okay. And what do we get? How big is that angle?
33.
Right about 33 degrees. Okay. Remember, if you're using a calculator phone, a phone calculator, you have to do it backwards. So 22 over 40, and then second sign. All right, more examples to look at. So in these, we're going to look in these top questions at angle A for each of them. And I want us to set up all of the possible fractions. So we're going to look at what the sine is, the cosine, and the tangent, but focusing always on angle A. So for the first triangle, if I do the sine, what am I going to get?
8 over 17.
8 over 17. Sine is opposite over hypotenuse. So we want to pick opposite of A, which is 8, over hypotenuse, which is 17. What about cosine? 15 over 17, the adjacent side over the hypotenuse. And what about tangent that we learned yesterday? 8 over 15, opposite over adjacent. So even though we did it yesterday, you can't forget it, and it could still be an option in solving a problem. Okay, so you might still use your tangent sometime in tonight's homework. So in the second one, if I focus again on angle A, what do I get for the sine? And the cosine? And the tangent. Okay, good job. For the last one, we're just given our letters. There's no numbers there, so our sides are A, B, and C. Our angles are A, B, and C. And again, we'll focus on A. What's the sine of angle A?
A over B.
Which one's the hypotenuse? B. Sine opposite over hypotenuse, and hypotenuse is always across from that right angle. And what's the cosine then? B over C. And tangent? A over B. Tangent doesn't use the hypotenuse, so opposite over adjacent. Okay. At the bottom, the 4 questions with the blanks are just practice plugging in the calculator, making sure we're hitting the correct buttons. So sine 24 gives what approximately? About 0.4. Cosine of 57? About 0.5. Then what do I need to do for these last two? And the blank I'm trying to fill in is the angle value. Second. So second cosine of that 0.9659 gives what for an angle? 15. And the last one?
Wait, how did you find that?
Yeah, we can kind of round that up to 6. It's about 5 point something. So to find that, again, when we're looking for the angle value, we press second first on our calculator. So for that, we'll do the cosine one. We would type in second cosine and then the number amount. Okay, when we're solving for the angle value, that's when we have to press our second button. Okay. In these last ones, we want to look at some different ways we could set up the problem. Since we have multiple trig functions that we could use now, that means that everybody might not necessarily solve the problem the same way. That's fine. You have options of what trig function to do. Some ways will be a little bit easier than other ways. So, in the first triangle, let's say that I want to use the sine function. What is sine supposed to be? What two sides? Opposite and hypotenuse. So if I'm doing opposite, I'm trying to solve for x, at x. So which angle do I want to pick then?
41.
41. So sine of 41 would be x over 100. It will always be easier for you to solve if your variable can be on top of the fraction. Okay? Could do a cosine, but it's going to be easier if we can get our variable on top of the fraction. So if we do want to do a cosine, cosine uses what two sides? Adjacent and hypotenuse. So which angle would I want to pick then?
Is that a 49?
The 49. Yep, would give us the adjacent over the hypotenuse. And if you're only given one of those angles, you could still find the other one, right? What would we do?
Add the angle, the given angle to 90.
Yep, add up what we're given and subtract out from 180 for a triangle. Okay. So you could use either sine or cosine to solve this problem, depending on which angle you place your focus. Okay? What about in the other one? If I wanted to do sine, which angle would I need to use?
35.
The 35. And that would be x over 8. And if I wanted to use cosine, then I would do the 55. Would be x over 8. Okay? So for sine, we're using an opposite, and for cosine, we're using an adjacent. Okay? So you may set things up differently than your neighbor, depending on whether you choose to do sine or cosine, but you could still get to the same place in the end. Okay? So homework tonight is from lesson